Have you ever wondered why wet clothes dry on their own? Or how a few drops of petrol seem to vanish in seconds? Even a puddle on the floor quietly disappears without a single bubble. These aren't magic tricks, they're everyday signs of a fascinating process called evaporation. It's when a liquid turns into gas, often without even reaching its boiling point. But how does it happen? What controls it? And why does it leave things feeling cooler? Let's dive in and uncover the science behind evaporation, one invisible change at a time. So, what exactly is evaporation? It's the process where liquid particles at the surface gain enough energy to break free and escape into the air as gas. Unlike boiling, which happens only at a fixed temperature, evaporation can occur at any temperature, even on a cool day. But here's the twist: only the most energetic particles near the surface manage to escape. And when they do, they take that energy with them. What's left behind? A liquid with less average energy, which means it cools down. That's why evaporation doesn't just dry things, it also makes them feel cooler. This is why scientists call it a surface phenomenon, because it all begins right at the top. Let's try out a simple yet powerful textbook activity to see evaporation in action. Step 1. Take 5 milliliters of water in a test tube and place it near a window. Step 2. Pour another 5 milliliters into a china dish and place it under a fan. Step 3. Take a third dish with water and place it inside a closed cupboard. Now we wait and observe. The dish under the fan dries the fastest. The one near the window takes a bit longer. And the one inside the cupboard? It barely changes. So, what's going on here? These simple observations give us a big clue. Something is affecting how fast evaporation happens. And that brings us to the next big idea: the factors that control evaporation. Now that we've seen evaporation in action, let's understand what controls how fast it happens. Here are the 4 key factors that affect the rate of evaporation. Surface area. The wider the surface, the more particles can escape. That's why clothes dry faster when they're spread out flat, not bundled up. Temperature. When the temperature rises, particles gain more kinetic energy. That means more particles can break free, so evaporation speeds up. Humidity. Humidity is the amount of water vapor already present in the air. If the air is already moist, there's less room for more vapor, so evaporation slows down. Wind speed. Wind blows away the evaporated molecules from the surface. This clears the space for more liquid particles to escape, speeding up evaporation. Put all 4 together and you'll see why a hot, dry, windy day is perfect for drying clothes and a cold, humid day is not. Evaporation isn't just science in textbooks, it's happening all around you. Ever wondered why sweating cools you down? As sweat evaporates from your skin, it absorbs heat from your body, carrying that energy away. That's evaporative cooling in action, nature's own air conditioning. Why do people sprinkle water on rooftops in summer? Because as the water evaporates, it draws heat from the hot surface, lowering the temperature. And here's one you've definitely felt: perfume feels cool when sprayed, right? That's because the volatile liquid evaporates quickly, pulling heat from your skin as it turns into gas. In every case, the particles that escape during evaporation are taking energy with them, leaving the surface they came from cooler than before. Let's apply what we've learned with a quick numerical example. Imagine someone loses 1 kilogram of water through sweating during a workout. If the latent heat of vaporization of water is 22.5 multiplied by 10 to the power of 5 joules per kilogram, how much energy is lost from the body? Step 1. Use the formula heat equals mass multiplied by latent heat. Step 2. Plug in the values. Heat equals 1 multiplied by 22.5 times 10 to the power 5, which equals 22.5 multiplied by 10 to the power 5 joules, or 2.25 million joules of energy. That's a massive amount of energy lost silently through evaporation. Now you know why you feel tired and cool after a heavy workout. Your body is using evaporation to keep you from overheating. Let's quickly recap what we've learned about evaporation. It's a surface phenomenon. Only the top layer of liquid participates. It happens at any temperature, not just when boiling. It causes cooling because high-energy particles escape and take heat with them. And the rate of evaporation? That depends on surface area, temperature, humidity, and wind speed. From drying wet clothes to cooling your body after exercise, and even chilling rooftops in summer, evaporation is quietly working all around us. But what about the opposite process when gas turns back into liquid?